Hi everyone, welcome back to another Algebra 1 tutorial. In this video, we'll be going over more functions. Writing functions. So writing functions are useful for calculating rates. For example, suppose a manufacturer earns $10 per pack and makes 70 packs of batteries per minute. And we're told to write a function rule for it. So for this function, we could write y as the money earned and x as the time. So here we would say that the amount of money earned is based on the amount of time. So since the manufacturer makes 70 packs of battery and each battery pack costs $10, he would make 700 packs per minute. So we could do y, so it will be time in minutes. We could do y is equal to 700 times the time in minutes. And this would be our function rule. And what this is basically saying is the total number of money earned is based upon the number of time in minutes multiplied by 700. So now let's determine relations. So suppose we're given the following table and we have x over here and y over here, and we have the following values 1, 2, 2, 4, 3, 6. So from here, if we look closely, we can see that over here, if we multiply it by 2, 1 into 2 is equal to 2. Similarly, multiply by 2, 2 into 2 is equal to 4. And similarly, 3 into 2 is equal to 6. And here, we can see that the x value is equal to half the y value. So we would get it as y is equal to 1 by 2x. Because if we did 6 into 1 by 2, it would give us 3. And here, 3 is the value. So our function rule for this function would be y is equal to 1 by 2x, or half x. Independent and dependent variables. So in a function, there are two variables. There's the independent variable and there's the dependent variable. So the input of the function, which is the x value, is an independent variable. Similarly, the output of the function, aka the y value, is the dependent variable, which basically means that the y value depends upon the x value. So what that means is y is equal to x times something, x divided by something, x plus something, or x minus something. So suppose we look at an analogy. So we have, to turn on the light, we need to flip the switch. So flipping the switch is an independent action. However, the light turning on is based upon whether you turn the switch or not. So that's one way you could think about it. If you turn on the light, then it doesn't affect the switch. If the light turns on, it doesn't affect the switch. But if you flip the switch, then the light turns on. Function notation. As we talked about earlier, function rules are the value of y with x altered, like y is equal to 5x. So function notation is like so. Suppose we have x, which is an independent variable, and we have y, which is a dependent variable. Then the function notation for y is f of x is equal to x being altered. So here we would get f of x is equal to 5x, since what they're basically trying to say here is f of x is equal to y, or f of x is output, so that's dependent. Okay, now let's do a few more problems. So suppose we are told to identify the independent and dependent variables. So a small bottle costs $2. A large bottle costs $4. And we're asked to find what is the independent and dependent variables. So if it's $2, it does not affect that if it's a small bottle or not. However, if it's a small bottle, then it has to cost $2. So we could say that these are the independent variables and these are the dependent variables. Okay, we're told to evaluate the following functions with input values. So let's do this one. F of x is equal to 3x plus 2, and we're told to find x, or f of x, when x is equal to 1 and negative 1. So for this one, all we need to do is substitute in the values. So 3 into 1 plus 2 is equal to 5, and 3 into negative 1 plus 2 makes this a negative, because negative 1 times positive 1 always gives a negative number. So negative 3 plus 2 is negative 1. So our two y values, or basically f of x, is 5 and negative 1 correspondingly. So we are given a set of coordinates on the coordinate plane: 1, 4, 2, 7, 3, 10, and 4, 13, and we're told to find a relationship. So for the first one, if we add 3, it gives us 4. However, if we add it to the second one, we get 5, which is not equal to 7. So it's not add 3. However, what if we multiply 3 and then add 1? So multiply into 3 and then we add 1. So yeah, we get 4. 2 times 3, which is 6, and then 6 plus 1, which is 7. That also works. 3 times 3, which is equal to 9, plus 1, which is 10, which also works. Finally, 4 times 3, which is equal to 12, and 12 plus 1, which is 13, which also works. So here we could get the function rule as y is equal to 3x plus 1. Graphing functions. So whenever we are told to graph functions on the coordinate plane, we're either given a y is equal to, or x minus y, or something on the lines of that. Suppose we're told to solve for negative x plus y is equal to 2, and given a set of domains 0, 1, 2, and 3, we would solve it like so. First, we would isolate the y value on one side to get y is equal to 2 plus x, which is basically f of x. And we would substitute in the values to get y is equal to 2 plus 0, 2, 2 plus 1, which is 3, 2 plus 2, which is 4, and finally 2 plus 3, which is 5. So our 4 y values would be 2, 3, 4, 5. So now let's graph a few functions. So we're given f of x is equal to 6x plus 4. So for this one, we'd have to get a set of values which we could use. So let's get 4 values for x, which is -2, -1, 0, 1, and 2. So usually this is the most common set of values used as a domain or like a test domain. So let's substitute in the values. So 6 and a -2 is -12 plus 4 is -8. So -2 gives us -8. And then -1 into 6 is -6 plus 4, which is -2. So -1, -2. Then 6 times 0 plus 4 is 0 plus 4, which is 4. So, and finally -1, 1, and then that gives us 10. And then 2 times 6, which is 12, plus 4, which is 16. So 2 gives us 16. And if we graph this function, usually whenever there's a positive value over here, then we can assume that it's a positive line. So our line would look something like this. And let's do one last problem. So in this problem, we'll be looking at a special type of figure when graphed, which is known as a parabola. So what a parabola is, it's a figure, a U-shaped figure, which is curved kind of, and it looks like so. So suppose we were told to graph f of x is equal to x squared. So first we would take our test values, -2, -1, 0, 1, and 2. So -2 squared would give us 4, -1 squared would give us 1, 0 squared was 0, 1 squared is 1, 2 squared is 4. So if on a graph, if we looked at these values, so this is the x and y, so 1, 2, 3, 4, okay, and then -1, 2, 1, 2, so -2 gives us 4, -1 gives us 1, 0, 0, 1, 1, and finally there. And this is a parabola for this figure, or this function. So now let's look at scatter plots and trend lines. So first of all, what is a scatter plot? So scatter plot is a graph or a plot where multiple different points are plotted which are not in relation with each other, like so. Or there are many different types of scatter plots with different correlation. So what is a correlation? So correlation is the relationship between two data sets. For example, over here we can see that it has a negative correlation, because if we try to make it out, we can see that the overall trend goes downwards. So we can say that this has a negative correlation. However, if we looked at another figure like this, where all the points are just plotted randomly, then we cannot conclude whether it's a positive or negative correlation, since all the points are plotted like so. So this would be no correlation. And similar to the negative correlation, if it goes upward, if all the points show an upward trend, then this means that it has a positive correlation. So there's positive, negative, and no correlation. So finally, let's look at trend lines. So as shown before, correlations are just the overall trend. However, if we would want to show a defined line which collectively represents each of the points. For example, this line, this would be called a trend line. And this is usually to show a trend. For example, here it shows an upwards trend. So let's do a few problems. So here we are told to describe the correlation, and as you can see here, a lot of the points are going upwards, so we describe this as a positive correlation. And similarly, if we see all the points going negative, like this one, we could say that it has a negative correlation. And now let's do a problem where we're told to identify the expected correlation. So the volume of water poured into a container and the amount of empty space left. So the volume of the water poured into the container is basically the amount of water which is poured into the container, which fills it up. So the volume of water would be this amount of water over here. This is the volume of water. So, and we're also asked to find the amount of empty space left in the container. So if there's more water in a container, then there's less empty space. So this one, let's just say this one has 100 milliliters and this one has 50 milliliters. And this is empty space and this is empty space. So if we look at the figure, it becomes obvious that the one with 100 milliliters has less empty space than the one without 100 milliliters or 50 milliliters, which is actually half of 100, right? So we can make a conclusion that it would have a negative correlation, like the expected correlation would be negative. Thanks for watching. Make sure to like and subscribe if it helped.